We're going to continue with our study of radicals, although we are pretty much restricting our study of radicals to square roots. You can multiply any two square roots. All you have to do is multiply their radicands. And you can divide any two square roots. You just divide their radicands. Addition and subtraction is quite different. You can only add or subtract, and I'm abbreviating that, like radicals. Like radicals are similar to like terms. They have the same index. In other words, a square root and a cube root cannot be like radicals. They have to have the same index. They have to have the same radicand. So if you had the square root of 3 and you wanted to add the square root of 3 to it, you can do that. You simply say that you have 2 square roots of 3. It's kind of like adding x and x, and you get 2x. If you have 5 times the square root of 3, and you want to add 7 times the square root of 3, you end up with 12 square roots of 3. So you can only combine those that are like radicals. Now, if they're not like radicals, it could be that if you simplify them, they will become like radicals. So let's take a look at some problems. I'm going to have to give myself a little bit of workspace. It says subtract the square root of 125 minus the square root of 245. Now those are not like radicals, but they're not simplified either. So over here, I'm going to have my work. I have the square root of 125. Can you simplify that? Well, because it ends in a 5, I recommend you seeing if 25 will go into it. And it does. 25 goes in there 5 times. So I can factor that as the square root of 25 times the square root of 25 times the square root of 5. What is the square root of 25? It is rational 5, and then I leave that one under the radical. The next part of my work is to simplify the square root of 245. But perhaps 25 goes into it. We'll see. If you take 245 and divide it by 25, it does not go in evenly. So what should we try? Well, let's go over here and take 245. What do you want to divide into it? Well, you can try a non-perfect square, but that's kind of a risky process. So it's not even, so there's no point in trying an even one. Let's try 9. We're just testing. 245 divided by 9. Nope, 9 didn't work. Let's try a larger, but it needs to be odd, because if it were an even, this number would be even. Okay, let's see, we've tried 3 squared is 9. We don't try 4 squared. 5 squared was 25. We've tried that. We don't try 6 squared because that's even. 7 squared. Let's try 49. So 245 divided by 49. Yes, it goes 5 times. So this is the square root of 49 times the square root of 5. That was a perfect square. So that's 7 times the square root of 5. So let me go back and mention something to you. If the radicand is odd, then it will not have an even factor. It will have only odd factors. So that will restrict a little bit of what you're going to test. If it is even, then it will have even factors, okay? Or at least one even factor. Let's go back up to the problem. This is 5 times the square root of 5 minus 7 times the square root of 5. Now they're like radicals, and I do 5 minus 7 is negative 2 times the square root of 5. The most challenging part of working with radicals is probably figuring out what to use to simplify it. You can randomly test things, but using the concept that if it's even, well, start with 4. If it's odd, it's got to be an odd perfect square. So try 9, try 49, try 25. Maybe that will help a little bit. Okay, let's look at number 2. Cube roots. This problem actually has been deleted from your homework because we were not working with simplifying cube roots. So let's go ahead and go on. That problem is no longer in your homework. The next one, we have quite a few to look at. And I'm going to give myself some workspace. I have 3 times the square root of 75. I have to keep the 3. 75. Well, what radical do you want to try? Well, it ends in a 5, so I'm going to try 25. And yes, it is 25 times 3. So keep the 3. The square root of 25 is 5 times the square root of 3. That becomes 15 times the square root of 3. Next one, I have 2 times the square root of 50. If you want to bring the negative sign with you, you can, or you can just put it in when you send the problem back. So I'll keep the 2. What's a perfect square that goes into 50? Well, it turns out it's 25 times 2. You could have tried 4 and some others, but I bet most of you recognized that if it ends in a 5, I said that earlier, but if it ends in a 0, there is a chance 25 is the perfect square. So keep the 2. The square root of 25 is 5 times the square root of 2. That becomes 10 times the square root of 2. Last one, square root of 12. Let's see, it's even. I will try, and I know 4 goes in there. So it's the square root of 4 times the square root of 3, which is 2 times the square root of 3. All right, I have simplified each one of those radicals. So I have 15 times the square root of 3 minus 10 times the square root of 2 plus 2 times the square root of 3. Only these two are like radicals. So 15 square roots of 3 plus 2 gives me 17 times the square root of 3. The other term is not like it, but I do just have to write it down. Minus 10 times the square root of 2. Okay? Let's look at another one. Work. I have 4 times the square root of 25. 25 is a perfect square. I simplify this by simply saying it's 4 times 5, which is 20. Then I have a minus 13. There's nothing to do with that. And I have the square root of 5, and I know I can't simplify the square root of 5. So this has become, the first term became 20 minus 13 plus the square root of 5. 20 and 13 are both rational numbers, so that gives me 7 plus the square root of 5. All right, let's look at one more. We've got a good bit of work, I think, to do on this one. I have 8 times the square root of 125. The more you work with these, the quicker you begin to recognize that 25 will go in there. So that's the square root of 25 times the square root of 5. So I hope the next time you see the square root of 125, you'll remember this factorization. So that's 8 times 5 times the square root of 5, or 40 times the square root of 5. Next, I have 5 times the square root of 12. That's 5 times 12. What's a perfect square factor that goes into 12? The square root of 4 times the square root of 3. 4 times 3. It would not do you any good to say 6 times 2 because neither of those are perfect squares. So that gives me 5 times the square root of 4 is rational 2 times the square root of 3. That becomes 10 times the square root of 3. Last, I have 5 times the square root of 45. 45. Can you think of a perfect square that goes into 45? How about 9? This is 5 times the square root of 9 times the square root of 5. Keep the 5. The square root of 9 is rational 3 times the square root of 5. Or 15 times the square root of 5. Going back to the problem, I have 40 times the square root of 5 minus 10 times the square root of 3 minus 5 times the square root of 5. 15 times the square root of 5. These two are both square roots of 5, so those are like radicals. 40 minus 15 gives me 25 square roots of 5, and then minus 10 times the square root of 3. You can't do any more simplifying than that. So you will begin to get a little bit more comfortable with simplifying radicals the more that you work on it. 45, you'll see a 9 inside it. 12, you'll see a 4 inside it. 125, you see 25 inside it. The more you practice, the more you'll recognize what the what the largest perfect square factor would be. Okay, you work on yours.